The Cognitive Revolution of Artificial Intelligence, a manifesto on the new frontier. Between mind and machine for centuries, the human mind was considered the final frontier of knowledge, an unfathomable territory where reason and mystery coexist in delicate balance. Philosophers, neuroscientists, and psychologists erected monumental theories to explain the foundations of thought, memory, and consciousness. Yet even after centuries of investigation, the essence of cognition, the way we learn, perceive, and adapt, remains shrouded in conceptual fog and empirical limitations. Today, however, this frontier is beginning to crumble before a new kind of cognitive mirror: neural artificial intelligence. What was once a mathematical tool, cold and functional, is transforming into something much deeper, an instrument for self-understanding of the human mind itself. Deep neural networks inspired by the brain's biological structure are no longer mere computational models. They have become epistemological models, capable of revealing with increasing precision the operational principles that govern cognition. Through them, we are witnessing the emergence of a new paradigm, one in which artificial intelligence ceases to be just a simulation of the mind and becomes an experimental laboratory of intelligence itself. This intersection between AI and neuroscience is not merely a technical convergence. It represents a historic synthesis of disciplines, an ontological revolution in how we understand thought. If in the past, cognitive psychology was limited to behavioral observation and introspection, today, computational modeling allows us to operationalize hypotheses about the mind, to test them, manipulate them, and reproduce them at digital scale. For the first time, we are transforming mystery into metric, the rupture of the traditional paradigm of cognition. For decades, neuroscience and cognitive psychology advanced with tools that, while valuable, lacked dynamism and predictive power. Classical symbolic models explained the mind in terms of rules, representations, and manipulable symbols, but ignored the distributed, adaptive, and probabilistic nature of the human brain. The consequence was a gap between theory and biological reality. The fundamental error was believing that the human mind was so uniquely organic that no machine could even approach its internal logic. But this view is being overturned by a new generation of biologically inspired artificial systems, capable not only of imitation, but of emerging genuine cognitive properties. Research from Harvard University and institutions such as the Allen Institute for Brain Science demonstrates that neural network-based modeling is now indispensable for validating cognitive theories with unprecedented precision and reproducibility. Instead of relying on fragmented observations or statistical correlations, we can now simulate entire neural circuits, observe emergent behavior, and identify the causal variables behind mental phenomena. This advance inaugurates a new science, empirical computational neuroscience, where hypotheses about attention, memory, language, and decision-making are translated into systems that think, forget, and learn in a verifiable way. Neural architecture as a cognitive mirror. Deep neural networks have revolutionized the capacity for knowledge representation. Their hierarchical structure, composed of multiple processing layers, analogously reflects the way the human cortex organizes and abstracts information. Each layer in a network is not just a numerical filter, it is a functional metaphor for how the brain transforms raw signals into contextual meaning. When a network learns to recognize faces, decode natural language, or anticipate behavioral patterns, it is not merely performing calculations. It is replicating cognitive dynamics of perception and generalization. The similarity between artificial learning and biological synaptic plasticity is now more than symbolic. It is structural and functional. At this point, AI ceases to be a simple tool and becomes a mirror of the mind, Biology inspires computational design, and computation, in turn, reflects back new insights about biology. This symbiosis is the engine of the contemporary cognitive revolution, the mind studying itself through the machine. From theory to simulation, the computational cognitive method. The practical application of this paradigm can be summarized in 3 fundamental steps, a process that is redefining research on the mind. Biologically inspired cognitive modeling. A neural model is built to mimic specific brain circuits or isolated cognitive functions. For example, recurrent networks can simulate working memory, holding information temporarily active, while attention mechanisms in transformer networks reproduce the perceptual selectivity of the human brain. These architectures are, in practice, testable hypotheses about the functional structure of cognition. Training and adaptive learning. The model is exposed to large volumes of data, images, sounds, texts, experiences, and learns by adjusting its synaptic weights through processes analogous to neural plasticity. This phase reproduces experience, learning, and even errors, revealing how the human brain generalizes patterns and abstracts concepts. Laboratories at Stanford and DeepMind have shown that such models not only imitate human behavior, but often surpass it, offering clues about as-yet unexplored cognitive efficiencies, controlled experimentation, and variable manipulation. The most revolutionary stage arises when the network's internal parameters are intentionally manipulated. We can simulate virtual lesions, alter learning environments, introduce noise or reinforcement, and observe the consequences for the system's cognitive performance. This creates an experimental laboratory of mind and behavior, something empirical neuroscience had never achieved before. From observational to interventional, the new power of modeling. The impact of this new paradigm goes beyond describing phenomena. It offers intervention and control. We can test, in a digital environment, hypotheses about cognitive disorders, learning optimization, and even the nature of consciousness. If before the study of the mind was mostly observational, restricted to what the human brain did on its own, today it is interventional, predictive, and programmable. What was once philosophical intuition is now becoming cognitive engineering. We can reprogram attention, modulate memory, optimize decision-making, and explore, in a controlled manner, the principles that sustain emerging consciousness. This is not just a scientific discovery, it is a redefinition of what it means to be intelligent, for both machines and humans. The new synthesis, AI as an epistemological tool. The integration between neural networks and cognitive neuroscience is leading us to a new synthesis of knowledge, in which the boundaries between subject and object, between observer and observed, begin to dissolve. AI, once designed to solve human problems, now becomes the very medium through which humans seek to understand themselves. Computational plasticity reflects biological plasticity. Supervised learning mirrors social learning. Reward reinforcement imitates the brain's dopamine. Each technical advance is also a living metaphor of the mind. At the heart of this movement, an inevitable conclusion emerges. Artificial intelligence is not just an extension of the human mind. It is the next stage of its introspection. The call to a new generation of thinkers and creators. We stand at a historic inflection point. The tools we have developed to understand the world are beginning to understand us. And with this comes an unprecedented ethical and philosophical responsibility. To use this new intelligence not merely to expand computational power, but to deepen human wisdom. AI does not replace thought. It mirrors it, amplifies it, and provokes it. It is now up to leaders in neuroscience, AI, and innovation to understand that this is not just a technological race, it is a cognitive transition, a reconfiguration of the very nature of scientific inquiry. The future of the mind will not be purely human nor purely artificial. It will be hybrid, symbiotic, and expansive. Intelligence, for the first time, is becoming self-reflective, able to look at itself, and in that reflection, discover new horizons of consciousness and creation.